How are you guys doing today? Good.
You have to approximate it, like
Huh?
like do you have to actually approximate it?
No, because you're not allowed to use calculator.
Why do they make this approximate?
In the homework, you're allowed to use it, but in the exam, you're not allowed. So that's why in the homework, they're asking whatever.
So you say like if it's a square root or if it's
In the exam, if it's a square root that is not simplificable, you just leave it alone. But in the homework or in the quiz, just follow the direction. If they said leave the radical answer, leave it. If they say approximate, that means you choose calculator to find the decimal number. So, any question before we start? Any comments, concern, complaint? So my goal for today is to do addition, subtraction of radical, addition, subtraction, multiplication, and then if you have time, then solving radical equation. The division of radical, we're going to do it after the exam, 10.5 system. Okay. So to refresh your memory, the last thing we did was multiplying radicals. When you have monomial times monomial, monomial is only one term. So one term times one term, you multiply number with the number, variables with the variables, and then you simplify. For numbers, you look for the same number radical many times. You leave those numbers alone under one radical, and whatever is left over, you leave that alone under another radical. So the radical and the square, the power cancel out. You get a free number and something that is another. For variable, you divide the power with the radical. What type of radical you have? The remainder is the power inside the radical. The whole number is the power outside the radical for the variable. And then at the final answer, you just put the free with the free, and then inside is the inside. If you don't have the multiplication, you do the same thing still, you simplify. Factoring the number and figure out how many times do you have the same number radical many times, you put them outside, and something not free goes inside, and then you variable, for each variable you simplify them separately. Division is the same thing, you convert two radical into one radical, do the inside first, and then do the simplifying. And then the last thing we did was, what if you have a polynomial inside the radical? As long as you have the power and the radical the same thing, they cancel out, but the answer, the whatever remains, has to be positive. So in order to indicate that the result has to be positive, we put them inside two bar, we call them absolute value. And that was all about radical. And now we are going to do two things that is not related to radical. Quiet. It's just there. I don't know why. The first thing is how do you find the distance between two numbers? So to find the distance between two numbers, you can memorize this formula. It says take the differences of the x's, square the quantity so they become positive, and then take the differences of the y's, square that so they become positive. So the square guarantees that this result will be positive. Same thing, the square guarantees that this result will be positive. And then you add two positive number and then take the square root. So that's why distance can never be negative. If distance is negative, that means something is wrong. And if you want to know how did we get this formula, it's easy. You have to look at the coordinate system. Let's say you have a number here, x1, y1, and let's say we have a number here, x2, y2. So enough number point. Let's say we have a point here, a point there. To find the distance between the 2 points, the straight distance here what we are doing here is we take how much their difference in xy's, like how much is the distance between x2 and x1, and how much is the distance between y1 and y2. So we take each distance and square that. So if this is, let's say, delta x and this is delta y, delta means the difference between the two numbers. So we get a right triangle. And right triangle says a square plus b square equals c square. So if this is a, this is b, and this is c, so c square is square root of a square plus b square. But what is a? It's x2 minus x1, and our b is y2 minus y1. Sorry, c square. So in order to find the c, we have to take the square root of this quantity. X2 minus x1 square plus y2 minus y1 square. X2 minus x1 or x1 minus x2, it doesn't matter. Why not? Because this power guarantees that whatever is inside, the result will be positive. So you can do x1 minus x2 or x2 minus x1, it doesn't matter. The square will solve the problem. Okay, so if you ever forget the formula, derive the formula. It's from a square plus b square equals c square. And that way you'll not forget y is plus, y is minus. Now we are going to use this formula to find out the distance between the 2 points given to us. No, not cover page. Come on, blank page. We are given two numbers, 2 points, -5, 3 and 2, -3. Let's say the first pair is x1, y1. The second pair is x2, y2. So the formula says, find the difference of the x's. So x1 minus x2 or x2 minus x1 doesn't matter. Just find the difference and then square that difference. Then add the differences of the y's and their square. And then whatever result you get, take the square root of the quantity. So what do I supposed to write? What minus what square? -5 minus 2 square. And then 3 minus -3. Good. We have to have double sign, double negative. And what happens to the double negative? Turns into positive. So -2, -5 minus -2. How much we get from here? -7. And then we have 3 plus 3. 6. Panda says do the inside first. So parentheses, exponent, parentheses, exponent, all these things. So we have to do inside first. You cannot cancel the square and the square root. It's not possible. So we have to simplify this quantity. What is -7 squared? 49. And then you are adding how much? 36. So inside first. 85. And 85 we cannot reduce by any perfect square number. So just leave it alone. And there will be one question in the exam about this distance. So first you have to tell me what's the formula for the distance, 1 point, and then find the distance between 2 points, either 1 point or 2 points, something like that. Okay. So definitely on Thursday you're going to see this. So memorize the formula, or at least remember how to derive it. Don't remember. The second thing is midpoint. So same scenario. If you have 1 point x1, y1, and another point here, x2, y2, and you want to find the midpoint, means exactly in the middle. So we can guess this is our middle, right? Exactly in the middle. So how can we find the middle point? Well, it's easy. It says take the half of x1 and x2 and take the half of the yn and y2. y1 and y2. That's the middle point. So how do you find half? We just add that 2x's divided by 2. That gives us half. For the half of the y, add the 2 y's divided by 2. It will give us half. So you're simply taking half of x's and half of y's. That's the middle point. So it's called midpoint. So it has a point format. An x value and an y value. And it has to be inside a parenthesis, and there has to be a comma between x and y value. So it's a point. It has a format x, comma, y inside parenthesis. The midpoint here, we add the two x values. So -5 plus 2, and in order to take half, we divide it by 2. Then we add the two y values. So 3 plus -3, but plus and minus turn into minus, so it's simply 3 minus 3. And you take the half of that. So it's a point, so you have to start with the parentheses, end with the parentheses, and in the middle you have to put a comma. So how much is -5 plus 2? -3. And what is 3 minus 3? 0. You cannot stop here. If you do, you are going to lose points, because you have to find at least how much is this. People don't know how much is this. So you have to tell them. For -3/2, if you don't know, you can leave it alone. But -3/2 is simple, right? What is half of 3? So you know this. It's -1.5. And what is half of 0? See? You don't have to memorize anything. Just use logic. What is half of 3 and half of 0? If you have no idea what is 0 divided by 2, think about this way. What is half of 0? Dividing by 2 means you're finding half. So half of 0 is 0. So you have to write this line. Especially, you must write 0. You can leave -3, have no problem, but you cannot leave 0/2. No, you have to memorize the equation. So memorize this. Memorize this. 2 points, 1 point for the distance formula, 1 point for the midpoint formula. And then 1 or 2 points for finding the distance between 2 points, and 1 or 2 points for finding the midpoint of 2 points. So let's say 1 point and 2 points, 3 points each here. Memorize.
The answer will be fractional.
If the fraction is big, leave it alone. But if it's reducible, let's say if it was 4/2, you definitely have to reduce. But since it's 3/2, you can leave it alone. But 0 over 2, you cannot leave that alone. If you do, you're going to lose points. So I'm warning you guys, 0 on the numerator is a very special case. You have to simplify that. And with this, you're done at 10.1, 10.3. Any question?
And will be given the 2 points, and we just know the
2 points will be given. You just have to find the midpoint of the 2 points and the distance between 2 points. How are you going to find them? You need the formula. So for formula, 1 point each, and for finding the midpoint and distance, 2 points each.
And if you don't find decimal on the
It's
last,
fine.
you can leave that, but the 0.
0 you cannot leave alone. You must simplify. Does it matter? It doesn't matter, right? Because there are 2 different formulas. You are going to 2 different scenarios. So there could be same point, could be different point. I'm not sure. I didn't make the exam yet.
Is this formula?
No. Distance comes from right triangle. A square plus b square equals c square. So c is the direct distance between 2 points. And what is a and b? A is the difference of the x's, and b is the difference of the y's. So a square means difference of the x squared, b square means difference of the y squared, and what is c is the square root of the quantity. So we know c square is a square plus b square in any right triangle, right? C is the hypotenuse. So a is difference of the x squared, b is difference of the y squared, and to get the c alone, it is the square root of both sides. So c is square root of that thingy, and that's the distance. Derivative is rate of change, like slope, not the distance. Okay, no question, right? So we are going to do addition and subtraction. Addition and subtraction is easy, very easy. There are 2 things you have to know. Actually, 3 things. First thing, in order to add and subtract, you have to have the same radical with the same inside. Same radical with the same radicand. For example, if you have, if you have square root of x and you're adding some other thing, that thing also has to have a square root of x. So you can add them. Adding is possible here, or subtracting. But if you have square root of x and square root of y, addition or subtraction is not possible. Okay? So in order to add and subtract, you have to have the same radical and same radicand, same inside. So same root, same inside. If you have same root and same inside, all you have to do is keep the same thing and add or subtract their coefficients. For example, if we have, let's say, square root of x plus 3 square root of x. We have same square root of x, square root of x. So we get 4 square root of x. 1 from the first one, 3 from the second one. The combination gives us 4 of them. That's all you have to do. First, you have to observe if you have the same root with the same inside. If you do, add or subtract their coefficients, but leave the radical part next to the coefficient. Now comes the second scenario. What if you don't have the same inside?
It's not 2. There's no number.
2 is the square root here. But what's the coefficient? How many square root of x you have on the first term? So this is square root of x. This 2 here is invisible. But I'm talking about coefficient.
Oh, okay.
I mean, how many of them you have? 1. So you add or subtract the coefficient, not the root. You leave the root and the inside same. Just add or subtract the coefficients. So if you have the same thing, you see how many you have, you just count how many and then add or subtract. For example, another example. 2 square root of y minus 3 square root of y. How many square root of y you are going to have? What is 2 minus 3? -1. So we are going to have -1 square root of y. So see, square root of y is just like a variable, any variable. So you just leave your square root or any type of radical part alone and add or subtract the coefficients you have. Question?
Two, right? One. Big one.
Tell me again.
We'll do two next to the ball.
2 next to the y. So 2 radical 2y.
Yeah.
And you have -3 radical y.
Yeah.
Okay. So do you have the same radical symbol? We do, square root. Do you have the same inside? No. One inside is 1y, other inside is 2y. In that case, it cannot combine.
With two and y.
2,
Separate, like
2y, and then?
two.
1 minute, check it.
I
So you have 2 inside 2y?
No, I just wanna like 2y is 2 times y, right? So can I do 2 and then 2 and then 2 and y?
But does it help you? You have 2y, y, like this? Or 2 times 2y?
2,
Okay, 2
yeah, inside the square root,
inside the square root,
yes. 2,
2,
and then inside the square root y. Another square.
another square root
Yes, and y.
here.
Yes,
And between the you have multiplication sign, right?
yes.
So square root of 2 times square root of y, you give square root of 2y, right?
Yes. So can I now do it or not?
And then you have -3 square root of y, right?
Yes.
PEMDA says do what first? Multiplication or addition subtraction? So if you do the multiplication here, what do you get? 2y. And then you still cannot do it. Because PEMDA is very, what should I say? It's very tricky or very strict. It says you have to do multiplication division first before you go for addition subtraction. But if you apply multiplication division, we get 2y, but the other one gives us 1y. Definitely they are the same, so you cannot add them or subtract them. So it's not possible. So if inside almost same, still you cannot add or subtract unless you're the exactly same thing. You have to have exact same thing inside in the radical, then you can add or subtract the coefficients. So first scenario, if they are not same and there is no way you can make them same, you cannot do anything. But there is another scenario. What if they are not same, but after you simplify, they become same? For example, 2 square root of 4x minus 3 square root of x. Definitely they are not same, right? One has 4x, the other has 1x. But can you simplify the 4x? Let me get a paper and then you'll see. Square root of 4x, 2 of them, and 3, 1 of them. So at first glance, it's not doable because I said are the same. But there is a trick here. What if we reduce this? Can you simplify square root of 4x? This is square root of 4 times square root of x. A simple idea, right? What is square root of 4? 2. And we have a 2 here. And now we have square root of x. So what do you have? 2 times 2, which is 4 square root of x. And we have 3 square root of x. Now can you subtract? How many square root of x we have? 1. So see, two scenario of unlike insight. If they are not same, either you give up because you cannot do anything, or you reduce if it's reducible, and then probably you can combine. When they are same or like you can see clearly. But when they're not same, the inside, there are two ways you can do it. Give up or don't give up, keep digging until you get what you want. Okay? Now let's do some fun example. These are already given, done for us. The first one says square root of 20 plus 2 times square root of 45. At first glance, 20 and 45, they're completely different numbers. So you may think, oh, we cannot do anything. But you cannot give up here. Because you can break down 20 and 45. 20 is 4 times 5. And 45 is 9 times 5. That means you can write square root of 4 times square root of 5 is square root of 20. And square root of 9 is square root of 5 is square root of 45. And then see, it's reducible. Square root of 4 is 2, square root of 9 is 3. So we get 2 square root of 5. And the coefficient 2 multiplies with the reduced term. We get 6 square root of 5. See, now we can combine because they both have the same inside square root of 5. The same radical. So you get 8 square root of 5. So sometimes we cannot do anything, but sometimes we can do something. So you always have to keep looking. Can you reduce? Can you? If you can, then go for it. If you cannot, leave it alone. Same scenario is cube root. This one is saying cube root of 54, 5 cube root of 16, and cube root of 2. All three numbers are different. 54, 16, 2, they all are different numbers. But can you reduce 54? Yes, it's 9 times 6, right? Can you reduce 16? We can already, no, we don't need 9. We are looking for something 3 times. So in 54, what number we have 3 times? Let's see. 9 times 6. But we are looking for same number 3 times. That means reduce more. 3 times 3, 3 times 2. So what number we have 3 times? 3. So it's 3 cubed and 2. Same thing, 16, you're looking for same number 3 times. So 16 is 4 times 4, but you're looking for 3 times, so you have to reduce more. And we see we have 2, 3 times. So yes, inside 54 and 16, there are some numbers we have 3 times. So you can reduce them. The only thing we cannot reduce is 2. So you can actually use a trick here. Whenever you're given many numbers, look at the smallest number. Can you reduce the smallest number? If you cannot, that means that's the inside you're looking for inside the other radical. So divide this by 2, and you have the same inside. So it's a trick. So see, 2 times 27 is 54. 2 times 8 is 16. Why did they divide by 2? Because this one is not divisible. So we want 2 inside here and 2 inside there. So just divide. This is part of the cube number, this is the part of the cube number. So we get some numbers back from them. And then at the end, all things have same radical in the same inside. So just add and subtract the coefficients. 3 plus 1 is 4. 4 minus 10 is -6. So you have -6 cube root of 2. And these are finalism question. You'll have at least one of these in the final. Addition, subtraction. Any question? No. Okay, let's try something fun. 4 square root of 5 plus 1 square root of 5.
5.
Good job. 5 square root of 5. Because we have the exactly same things. So just combine the coefficients. Oh, it looks bad. But actually it's not bad. What like terms do you see here? First of all, we have 6 and 7, right? They are like terms. So we can combine them. What is 6 plus 7? 13. And now how about these? Are these like terms? We have an invisible one here. So can you combine them? Do you have the same radical with the same inside? So how many of them we have? 5 and 1, 6 of them. Right? But you cannot live here. Why not? What do you observe here? This is reducible. This is y to the 6 over 2. Anytime something is reducible, you must reduce. So 2 goes to 6 how many times?
3.
3. That means our final answer is 13 plus 6 y cubed. Not going to get this in the exam, but this is for your homework and quiz. And you cannot combine 13 and 6. Why not? For the variable, they are not like terms. 6 has a y cube, 13 doesn't have y cube. We can only add or subtract if they are the same variable with the same radical or same power. Now comes something trickier. 4 square root of 7 minus 3 square root of 28.
Break up with 1 7.
Great. 7 is not reducible. That means our goal is to divide 28 by 7 and see if you can divide. Can you divide 28 by 7? How many times? 4 times. So we can divide 28 by 7. And we have square root of 4, square root of 7. But we still have minus 3 times here and 4 square root of 7 here. So 4 square root of 7 minus 3. What is square root of 4? 2. And we bring this down. So 4 square root of 7 minus 6 square root of 7. What is our final answer? Negative 2 square root of 7. So it looked like it wasn't, like it looks like we cannot subtract, but actually we could subtract because we could reduce 28 by dividing by 7. Now, is there anybody who is lost? Any question? Tell me where. Okay, question number 1. In order to add or subtract, what is our requirement? With the same inside. Same radical with the same inside. Do we have the same radical symbol here? Square root, yes. Do you have the same inside, same radicand? No. Since we don't have the same inside, we have two choices. Either we give up if it's not reducible, or we keep going further if it's reducible. Now, how do you know if it's reducible or not? We look at the smaller number. Which one is smaller, 7 or 28?
7.
So you cannot reduce 7, right? It's a prime number. But can you divide 28 by 7? That means you can reduce. So go ahead and reduce, and then you get that. So we divided 20 by 7 to get 4. So we split it into two pieces. Square root of 4 gives us 2, and 7 just takes 7. Now between all three things, we're in visible multiplication, which I made visible here. So 3 and 2 becomes 6, not 5. You're not adding, you're multiplying. So we have 4 of them given directly, and 6 of them we got after reducing. So 4 minus 6 is just -2. Instead of 7. Reduce.
How did you cancel the square?
How much is square root of 4?
2,
2.
so whatever we get, just.
You reduce. So if you want to see cancellation, it's like we have square root of 4. We have, come on. So we have square root of 4. So you're looking for same number twice. The square root, square part cancel out. The answer is 2. That's why square root of 4 is 2. Anybody else who is lost? How many more we have? Let's see. 1, 2, 3. 3 more. So let me write them down on one place. 2 square root of 80 minus 9 square root of 45. 5 square root of 4 minus 11. Oh, this is 24. This is 54. 24, 54, 5, 11. Okay, try these 3 and then you'll be ready for final and for that exam. You don't have to struggle alone. Talk to your neighbors.
And
Everything is
here. Four. And then
8 times 6 is 48.
yeah.
It's wrong.
Yeah. It's wrong with any more terms.
9 times 5
That's where that's it. Now, I know you. I know you.
Can you divide 8 by 2 by 2? So that's it. Divide all of them by 2. The smallest number we have 9 times 2. I know it's not wrong, but it's simple. Good, 9 times 2. Now we do. You did correct. Now it's going to You didn't have to, because I just started 9. It just makes me.
Yes. And then that's what you supply, right? So do that now.
Is this fine? Did I fine? I just started 4. So you have 4 and 3, 6 and 2.
That's why I did it. That's all.
It should go on the right number. Yes. Yes, 6 here and 2. So that's why it's better if you switch the position. Like 9 here and 2 here. We need a cross section 3 to do that. So
Use for two.
So we know square root 9.
And the other one.
4 sections.
Wait, there's one.
This is 4. So, minus 3 then 5, then is
Square root nine.
this is still minus 1.
No, it's not.
6 times 2, right? 4. And then there's conversation house. 1 gives 2.
That's just a square. On the line. Yeah. Oh, wait, no. Yeah. This is.
With this up.
24.
Yes. Now we have minus two squared. Plus two squared. Okay, this combined. Wait, the size.
Yes. And so.
Good.
You're basically splitting teeth. He's not a being everything else down. Two is not.
Really? One side is
Divides that by so that's into the three. I don't know. And this one can see whatever comes first. We take contribution division for the comes first. The division is present for the comes first. Also be there.
It's fine. So yesterday,
Yes, he makes his
yeah, yesterday. So yesterday.
Yes.
Yeah.
And then you turn around. Yeah.
Oh, that's because we didn't see the.
But I. It's like, debated my whole activity. And have to put it all the time. But yesterday I had to try to go find out on that. Accomplish that. I don't know.
When I
There's a few other people. But I'm probably gonna have to go there after class today.
the first
I
person
can't get on the tickets. And when I go on Friday, they sent the PDF. I tried to go.
Wait.
so I got
Tried to get
now the first down course. Office is the first by four.
It says that.
He had it. That was the Yeah. What comes with seasons that you I'm saying online class, actually, that's not
Well, luckily, we take out everything here, so, you know, I can show up, but I haven't.
That's what. So you. Start with a small.
Thank you. Okay. Okay. Thank you so much. I don't know, this semester.
Susan?
It's oh, yeah, like, he's like, I'm my email, it's like, oh. Thank you for listening.
One of the names, one of the names. That's when you attention. The first one, whatever you attention. No, I like them. That's why.
Yeah, these are fun.
Without going for this.
It's memorable. And the 45.
So like that was.
Good, see, if you look touch the wheel, it comes out on once.
What's the last one? No, 24. No, the 81. 81.
See, it doesn't score, that's the. This one, 45 is the sign. Now you know that you're looking for a side. So they have like. So they do. That will tell you what number you're looking for. One of them is 25 here. Now I see how this has speed and that's the last one. Great. It's level 16 and stuff. Yeah. What's two rules that don't have the I don't choose the rules. That's the 9. It implies the root of something. That's the if it still has a root, that means it's wrong. Square root of 16 equals that's square. The square root of 4 is
You got negative. Yeah, it's not very far.
when you apply the root, you cannot apply the equal. So you apply, you also radical on the 16 plus radical, that is the radical is Next is a minus u square. Okay, let's do it together.
Who would like to help me with the first one? Volunteer? Come on, guys, it's fun. Maria. 9 and 2. How about 8? 4 and 2. And we are using 2 because look at the smallest number inside. It's 2. That means you're looking for same 2 inside other 2 radicals. So square root of 9, square root of 2, square root of 4, square root of 2. And we have this 4 and we have this negative 6. And this is not reducible, so we bring it down. And then we know 9 gives us 3 without any radical. So it's 4 times 3 square root of 2. The 4 gives us 2. Okay. So 6 times 2 with the radical 2. And lastly, this is nothing to do, so we leave it alone. Multiplication comes before addition and subtraction. So we have to multiply 12 square root of 2 minus 12 square root of 2 plus 3 square root of 2. And surprisingly, we have the exact same 2 things here with opposite signs. So they cancel out. So answer is the leftover 3 square root of 2. Now 45 and 80. 80 is big, right? So leave 80 alone first. Look at the 45. What 2 numbers comes in your mind when you see 45? 9 and 5. Write the perfect square number first so that you can see the multiplication easily. So we have square root of 9, square root of 5, and we bring this down 9. That means this 5, we are looking inside this 80. One of them has to be 5. So 5 goes to 80 how many times? 16. 16 times. If you don't know, then divide. 5 goes to 8 once. We get 3. After the subtraction, we bring down 0. 5 goes to 30, 6 times. And bring down our 2. So we have 2. This gives us 4. We have 9. This gives us 3. Multiplication comes fast. So this is 12 square root of 5 minus 18 square root of 5. What's the answer? Negative 6 square root of 5. Yes, you can use 8 and 10. So let me show you if you use 8 and 10. Did I do something wrong?
Yeah.
9 and 3 is 27. Come on. You guys influenced me. 9 times 3 is 27, right?
2 times 4 is 12.
Oh, man. At least my negative is correct. How much? 19. 9 plus 7, 9, 8, 7. 19. So if you do use 8 and 10, no problem. Let me show you what to do if you use 10 and 8. Or 2 square root of 80. So if you use 8 and 10, no problem. But you're not done here. You have to keep reducing. So 8 is 4 and 2, 5 is 2 and 5. So you see 2 twice. So it's 4 times 4 times 5. So square root of 80 is square root of 4, square root of 4, square root of 5. So this gives you 2, this gives you 2, this is 5, and you have the coefficient 2. So how many you have? 1, 2, 3, 8 square root of 5. So yes, you can do it any numbers, but if you don't pick a perfect square number, the biggest perfect square number, you have to keep reducing until there's no more perfect square number inside. The last one, 24 and 54. Which one is simpler? 24? Actually 54, right? What two numbers comes in your mind? 9 and 6. That means we are looking for 6 and something here. 6 and 4. See? That's the trick. Start with the easy one. If you do it with the easy one, you can see automatically what number you're looking for inside the other one. So square root of 6, square root of 4, this 5 comes down, this 11 comes down. 5, this gives us 2. We get 3 from here. Some multiplication gives us 10 square root of 6, 33 square root of 6, right? And how much we have this time? Negative 23 square root of 6. So one of them definitely will be the final exam. Either addition or subtraction. Either with 2 terms or with 3 terms. But definitely you're going to see one of them. Definitely in this exam, but also in the final exam. Oh, I have to tell you what will be in this exam, but today is Tuesday. Okay, I'll tell you that later. So that's how we do addition and subtraction. We have to have same radical with the same inside. If you don't have the same inside, do something so we can have the same inside. If you don't have the same inside, you cannot combine them. You just leave them alone. Let me do one more example. One more. Let's say we have 2 square root of 8 minus 3 square root of 12. Okay. So 8 square root of 2 square root of 8 minus 3 square root of 12. And let's put another one. 4 square root of 50. 4 square root of 50. Now we have 3 different numbers. Which one you want to start with? 8, 12, or 50? 8. Which two numbers we have? 4 and 2. So if this is 2 and what? 25. Now if you want 2 here, you get 6 here. But is 6 a perfect square number? That means dividing by 2 doesn't help. So even though we can divide by 2, but we should not divide by 2 because 6 is not a perfect square number. So inside 12, what perfect square number we have? 4 and 3. So this one, we got something different. Not something with 2, we got something with 3. Square root of 4, square root of 2, square root of 4, square root of 3, square root of 25, square root of 2. We bring down this 2, we bring down this negative 3, we bring down this -4. So two of them have the same inside, but the other one doesn't have the same inside. Well, it doesn't matter. Let's see what do we do. This gives us 2 square root of 2. This gives us 2 square root of 3. This gives us, what is square root of 25? 5 square root of 2. So we do the same thing, we keep reducing, and now we know that we have to do the multiplication first. So 4 square root of 2, 6 square root of 3, 20 square root of 2. Now, is there anything that has the same inside with the same radical? These two. These two are like terms because they have the same radical with the same inside. That means we can combine them. They are combinable. So what is 4 minus 20? Negative 16 radical 2. And this one is not combinable. We cannot combine them. I can have to switch the position. Keep the position. Negative 16 radical 2. And this one is the only thing we cannot do anything. So we got something weird that we did not have before. But this example shows that not always you will be able to divide the bigger piece with the smaller piece. Sometimes you have to do different numbers. Our main goal is to get a perfect square number because we are working with square roots. Any question? So what do you prefer, the left side or the right side? Do you have any example? On the left or on the right? On the left? Okay. But in the final result, I cannot guarantee which one you will see. But it's good to know all the methods. So we did addition, subtraction, and I think the last thing will be multiplication. So the solving radical equation and dividing radical, we will do that after the exam. So after exam from chapter 10, we have solving radical, division, and then imaginary numbers, and then chapter 11. And we have 2 weeks. 2 weeks means 1, 2, 3, 4, 5. 5 lectures. We can finish them, right? Yeah. Multiplying radicals you already know because we already used many examples. So just like before, we distribute and multiply. So we distribute this, we distribute that. So we have 5 times square root of 2. We cannot multiply them because the 2 is inside the radical, but 5 is not. In order to multiply the radical, we have to have the same radical. 5 doesn't even have any radical, so how can you multiply? That's why you just put them together. You cannot multiply them, just put them together.
So, I don't know.
We cannot write negative square root of 10.
No.
We cannot write square root of 10. We cannot divide 5 with the 2 because 2 is inside the radical, 5 is not. However, can you multiply 5 with the 3?
Yeah.
Yes. What do you get? 15. Yeah. So if you don't have the radical, you cannot multiply the inside. You just have it outside as a multiplication. So this is same as 5 times square root of 2. The multiplication sign is invisible. Now we do the same thing. We have square root of 6x, and you're multiplying square root of 6. Then you're multiplying this square root of 6x times square root of x. Now this time, can you multiply that inside? Do we have the same radical here? Yes. As long as you have the same radical, and if the inside is positive, you're allowed to multiply them. So we get square root of 36x. Right? 6 times 6 is 36, and then x minus. We have the same square root. That means we are allowed to multiply the inside because both of them are positive. So we get square root of 6x squared. Are we done? No. The multiplication is done, no problem. But now what do you have to do? Simplify. So square root of 36, square root of x. You have to split them because square root of 36 is a perfect square number. And you have to split this square root of 6 because square root of x squared, because x squared is a perfect square number. So what do we have? 6 square root of x and square root of 6. What do you get from square root of x squared? They cancel out. We have x. Can you combine them more? Can you subtract them? In order to addition or subtraction, what is our requirement? We have to have what? Same root with same inside. We have same root, square root, okay. But do you have the same inside? No. So there is no way we can combine them. So we have to stop now. We cannot combine them anymore. So multiplication, as long as you have the same radical symbol, you can multiply the inside if the inside are positive. If the inside are not positive, if it says negative, bring out your negative as an I, and then you can multiply. And then when something is reducible, you always have to reduce. After reducing, if you have the same inside under the same radical, then you can combine more. If you don't have them, you cannot combine. Now comes something that will be in the final answer. 2 by 2 multiplication. No problem, we don't need to do FOIL, right? So these are first term. We are going to multiply this with that.
How many are we gonna get? No, how many of them are gonna get final? Like one in each or?
One multiplication, one addition, subtraction. There will be no division. Usually there is no division, but there will be solving radical one. So from radical, there are at least 3 questions. So we have 4 square root of 2 times 3 square root of 2. The first one. Then the second one. So we have minus 4 square root of 2 times the 4. Then it's the other way around. We have 7. So 7 times 3 square root of 2. This is multiplication. And this is 7 times the negative 4. If you write this way, you can see what's going on. But you don't have to write this line. The main thing is the next line. In multiplication, you multiply the number outside. So you get 4 times 3, 12. And if you have the same inside, just use a square. Instead of multiplying the inside, use a square power. So it's square root of 2, we have it twice. Yes, you can multiply 2 times to 4, but sometimes they tend to give big numbers. Like instead of 2, they give 23. So if you multiply 23 times 23, then you have to know what is square root of 23 times 23, you get lost. That's if you have the same inside, don't multiply them. Just use power. Why? Because we can easily cancel the radical with the power. Life becomes easy. So from here, we get 12 times 2, that gives us 24. Then you go to the next one. 4 radical 2 times 4. We multiply the number with the number. What do you have? 4 times 4? 16. And there is only one radical, which is radical 2. So when you have 2 radicals, as long as the answer is same, is the square. If the insides are not same, then multiply them. For example, here, the insides are not same, so you multiply them. But here we have radical 2 times radical 2, so it's radical 2 squared. Now the next one. What do you have on the next one? Good, 21 square root of 2. Because you are multiplying 7 into 3. And now the last one. Negative 28. Which 4? Okay, so if you want, you can write this way. Plus this minus that. Now observe the middle. Add the like terms. Negative 16 root 2 plus 21 root 2. They are same because they have the same radical portion. So how much we get from the inside? Negative 16, positive 21. Positive 5 root 2. 16, so 21 minus 16 gives you 5. And this one we just bring down. So plus 5 root 2 minus 28. And now observe these two like terms. 24 minus 28. How much? So negative 4, and then we have the extra 5 root 2. And now we are done. How is that? Which part is confusing? Did you understand the FOIL? Second line is FOIL. I did not think it is FOIL.
There was one part that where you put like, wait, didn't for 32 version times everything.
Times the integrals here.
Oh.
So 4 root 2 times 3 root 2. 4 root 2 times 3 root 2. Then 4 root 2 times negative 4. So 4 root 2 times negative 4.
Okay, yeah, not bad.
Previously, I switched the sign because when you multiply plus and minus, you get minus anyway. And then in multiplication, you multiply the coefficients with the coefficients. Inside with the inside, but if you have the same inside, then multiply this with the square, so they make sense of you. And why? Because they may not give you something smaller. They'll give you 23. So if you multiply 23 times 23, you have to multiply, and then you have to find what the square root of the number. So just one single time. So same thing, then multiply. This is the square. Here it doesn't have any radicals, so just multiply both of the whole. 7 and 3, just the coefficients, multiply them. This doesn't have any radical, just multiply.
Then after that, just like.
Combine like that. Square root, square part cancel out, so you have 12 times 2, reduces 24. And combine 28, so 24 minus 28 is 74. And these two are like terms because they are same thing. Square root of 2, square root of 2. So you combine their coefficients. Like this 16 plus 21, you see how this comes. That's it. Any other question from anyone? So how many questions I have? 1, 2, 3, 4. 4 questions. Let me write them together. So you have what? 13 square root of 13 plus 2 square root of 13 minus 2. And let me do the last one together. Okay. 5 square root of 13 plus 2, 5 square root of 13 minus 2. What do you observe? Yes, you can distribute, no problem. But before you even go to distribution, what do you observe? Do you observe anything?
X plus y and x negative 5, so x minus y squared.
Perfect difference of perfect squares. You have the same thing, addition and subtraction, just like this. X plus y, x minus y. When you the conjugates, we call them conjugates. The product is difference of perfect squares. So this is x squared minus y squared. So you don't have to use FOIL to distribute them. When you have two conjugates, means exact same two terms with the opposite signs. When you multiply them by FOILing, you get each one of them squared and the minus between them. So you can use this method. You don't have to multiply. You get the first thing squared minus second thing squared. That's the result. So 5 square root of 13 squared and then 2 squared. And then you use the distribution rule. Xy to the power n is what? X to the n, y to the n. So you distribute the power to both of them. 5 square and square root of 13 square. And we know what is 2 square, right? 4. What is 5 square? 25. And what is square root of 13 square? 13, because you can simply cancel them. The same thing. Then you just multiply these two. 25 times 13. 3 times 5 is 25 is 75. And then 1 times 25 is 25. So you get 591, 195? No, it doesn't make sense. How'd you get 12? Oh man, what's wrong with me today? It's 25. So this is 325?
Yes.
Yeah, makes sense because you have 13 of them. So let me erase this. So you have 325 minus 4, which is 321. So to save you time, you don't have to use FOIL if you're working with two conjugates. You can simply use the perfect square, difference of perfect square.
Do we get the same answer?
Same answer. So you can try this 3, but before that, let me tell you what will be in the exam. Okay. In case I forget later, it's better to tell you now. Review sheet. I did post the review sheet, right?
Yeah.
I don't have it here, so. Maybe I downloaded it. Let me see. Now. Okay, let me download from. Let me hit. I can use that, but then it will not be recorded.
Oh.
But if you need it in case, let me just go to bright space. That's. I think we have to do it all our life.
For the entire. Like, don't be selected right before.
Well, if you.
I think that's pretty nice.
The first, I'm not very English one. Right? And then it just.
Like balance to, yeah.
I think it's pretty nice. I don't think that's why would they have to provide? They always get out. Don't you think that it's.
Yeah, like sometimes one time ago.
They just elevator.
No, wait.
Very fine. So I don't know. I told them that they implemented more cameras. It didn't mean that they. So that's why.
Two of these. One will be from here, and one will be like this. Okay. One of these. What problems? Two of these. Two of these. I can actually tell you which two. These two. Obviously, the scenario will be different. Okay, like this function will be different. This function will be different. Increasing, decreasing will be different, but the idea will be same. Okay. So one with joint distribution and one with multiple choice joint distribution. Sure. Now, one of these, one of these. One, this. These are easy questions. So these question two, like what's the difference between having a negative inside or outside the parentheses? So question one, question two, two from question three, definitely four, definitely five. If it's outside, it's a multiplication. I. It's I.
From 4, 5, 1, and 1.
4, 1, 5, 1. But you have to memorize the formula. Memorize this formula, 1 point, and then find the distance, 2 points. Find the midpoint formula, 1 point. Find the midpoint from those points, 2 points. So one question, two here, one, two questions from here. I mean, this is one question in two parts. Now, one from addition subtraction. Either could be 2 or could be 3. Okay?
Just one.
Just one. From multiplication, 1 with perfect square and 1 with this. And I think that's it. 5 and 6 didn't have time, so we're going to do that after the exam.
So no 10.5 or no 10.6.
No. So you can relax a bit. So how many questions I see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Around 16 questions. 16. And now these are the 3 questions. Practice before you go, because we have lots of time.
Oh, we had a lot of.
It's only 38. See, during exam, you don't let me leave until 4. So stay until 4 now. Come on, my pen is not working.
We have 2 hours to do.
Almost 2 hours. In the final exam, you have to do 30 questions in 2 hours. So don't get to it my time. Bless you. Don't get too used to it the time I give in class exam. Oh, I didn't take the attendance today. I should.
Why do we lose the words? I remember when the first time I took the class,
Fast.
it was consistent, and now it's just inconsistent.
No, they told me the rule is this: the fast reflection 3 points, second reflection 3 points, and then the third reflection 0 point. So I was like, what's the point of doing the reflection if you don't get any point? So I split the 3 point using 2 and 1. So get some encouragement to do the third reflection. Question?
No, because the first time I had it, they had it consistent. It was always 5.
5 points.
Yeah, for each.
Really?
Yes.
He's doing it against the rule.
That was the first time we took all that.
It's against the rule. We're supposed to give only 3 points in the first exam and second exam. Third one is 0 points. See, he gave a few points. 3 points. Which other example? Or the review sheet? Oh, here? Okay. No problem. Oh, okay, go ahead. Ready? Okay, these 3 questions. Liliana here, Martin here, Christopher here, Axel here, Matthias here, Eliza here, Angel here, Handa here, Maria here, Ashley here, Exana absent, Jason here, Kathy here, Asimon's here, Kayla, Rachel, Rachel, oh, Alicius, Mariam, hey, Chanel, Jesse and Jonathan. So only one absent today.
Oh, I don't know. I could. Yeah, that's not great. Thanks for the question. Yes.
I got the distribution. I got the distribution. Distribution rate. 5% for 5%. Negative T for the 7.
The 0.4 doesn't have the 7.
You cannot multiply the same thing.
So 140.
One of the two is coming from here. You skip 5 brackets at a time. So this goes to this and this.
Yeah.
I'm on a roll. So quantity what is training and then is the semester. So you take one here. This one is once and once you have yes, and then you go to the next one. This one is you see, that's why this is called boil. The class now inside out. The first one. I think that's
I'm gonna go with this one. I'm used to this one. I don't have to study for now. Or pen.
Or even if you do have the money, the thing is, oh, you notice that why did it sitting there?
That's why I like this one.
So in my classes, in the class I take, all of my notes are in the
Oh, so you don't actually use it.
my calculator on that. That's where, doesn't matter. The person is the 5 considering as plus and partial minus. That means equal to your cost. That means you take B, you take B. You're right at this part. You just work on that turn. Oh, you should think of front and the back. And then I think it's 40 ways. Yeah.
This.
That's what this is. Or like, is it negative? No, 145. Oh. Oh, shit. Square root of 4. Okay. Okay,
So let's do it together. And let me do the easy one first. We have the same things. So we can just simply square them. Square root of 13 square minus 2 square. Square root, square cancel out. We get 13. 2 square is 4. The answer is 9. So whenever you have two conjugates, just square them out. That's it. Now for this one, if you find foiling method is hard for you, do the box method. 4 root 6, and then you have minus 5. 2 root 6, and you have 7. Okay. So you multiply this, you get 8 square root of 6 squared. That gives you 8 times 6, which is 48. Then you have to multiply this. 4 times 7 is 28. So you get 28 root 6. This color. And I already did this purple. You do this 5 times 2, negative 10 root 6. And lastly, green. And I already did green. Orange. This with that. So you get negative 35. Okay. And then you just combine like terms. These two are like terms, right? So 48 minus 35. And these two are like terms. So 28 root 6 minus 10 root 6. 48 minus 35. So you have 18 root 6 and this is 13. So answer is 13 plus 18 root 6. So if you find foiling is hard, do the box. Whatever is easier for you. Let me do this with foiling. If you don't like box, no problem, you're foiling. So you take one term, okay? And you multiply both of them here. So 5 square root of 7 times 4 square root of 7 plus 5 square root of 7 times 2. Then you go the other way around. We take green. Now I took green. Let me take purple. You take the next number, negative 3 and this. So negative 3 times 4 root 7 and negative 3 times 2. And now all you have to do is multiply. 4 times 5 is 20 square root of 7 square. That gives you 20 times 7, which is 140. Here we have 5 times 2, 10 root 7. Here we have 12 root 7. And this gives you 6. These two are like terms, so we get minus 2 root 7, and you bring down the 6. Now these two are like terms. These are numbers. So you get 134 minus 2 root 7. That's it. The common mistake I see in the exam is these signs. Make sure you have this sign in the middle. People forget to put the sign, and then at the end, you get wrong. So whatever you need help with, please go about those during your PLT tomorrow. And your exam will be on Thursday. Don't be late.
With this.
When I visit no, I heard this like.
Whatever.
Oh, yeah.
48.
Yeah.
48. Okay. So I'm correct up to here, right? 48 plus 12, 6. 4 times 3, 12. And 5 times 2 is 10. So 15.
I think it's 7 here, but there's no 7 here.
Oh.
So you miswrote something.
So that's
Uh-huh. So it's not 3 actually.
Maria, let's go on the board problem.
No problem. Hurry up.